Hi guys and welcome to today's video on this further maths course and the 5-number summary and the box plot. Whoop! It couldn't get any more exciting, could it? Well, it can indeed get more exciting and it's about to. So if you're here, you are obviously here to find out about a box plot, which we did a little bit in a previous video, and this wonderful thing called a 5-number summary. Stick with me and I will zip into that work in just a moment. But if you are new to my channel, hi, welcome. Lovely to see you. I'm Darren, otherwise known as the Maths Guru, and my particular style is a little bit mad, a little bit wacky, but honestly, I hated maths at school. And I think it's allowed me to help you guys be brilliant. So fingers crossed, if you like the video, at the end, leave a comment below saying thumbs up or let me know what I can improve. If you could do me the honor, please, of subscribing. There is a red arrow over there as well. That lets me know that you're actually watching these videos. I'm a small person trying to do a pretty large job in doing all these videos on my own, and your support is greatly, greatly appreciated. Now, as I say, by the end of this lesson, you're going to know what the 5-number summary is, what it tells us, what a box plot is, and how to use this 5-number summary to create a box plot, or to use the box plot to create or read off our 5-number summary. And most importantly, you're going to know how to use a CAS. Remember, this course is Australian, but valuable for all over the world. And over here in Australia, you're allowed to use technology to help you do this stuff. Thank you very much. Now, we've already dealt with in a previous lesson the median, the range, and the interquartile range. And if you haven't already seen the lessons, please go back and have a look. They're pretty awesome. We worked out that the range was all right unless there were outliers. And so we came up with a different way of looking at the spread of data, like Vegemite on a piece of bread or Marmite on a piece of bread. And we looked at the idea that, well, maybe we can ignore those outliers and look at the 50%, that middle 50% of data, otherwise known as the interquartile range. Now, I don't know about you, but I am fairly tired of being told I have to eat 5 pieces of fruit and vegetable a day. I'm sure it's very, very good for me, but I have to say I'm not a great lover of fruit, and I'm certainly not a great lover of vegetables. And so if I eat them, I do it under duress. It's such a shame that chocolate is not a healthy option. But lots of things in maths have 5 things in them. And obviously, one of those is, as I'm trying to get to here, this 5-number summary. So let's just kick straight in and say, well, what on earth is a 5-number summary? In the previous video, when we looked at the interquartile range, we actually had already come across those 5 important pieces of information. And what we always like to know about any set of data is 1, the minimum value of that data. 2, this thing called the lower quartile. That's where the sort of 25th% of the data is. This median, otherwise known as a middle value. The upper quartile, where the end of the sort of 75th piece of data is, and the maximum value. And actually, last lesson, or in the previous video, I actually did something called a box plot. And now we're going to do it formally. Box plots are also known as box and whisper plots, and they are freaking awesome. Draw one of these, and the next lesson we'll look at how you can compare sort of graphs with these and look at distributions about positive skew and negative skew and symmetry and all that type of stuff. But box plots are so amazing because what they do is split data into quarters. So we can look and say, well, there's a quarter of my data there, there's a quarter of my data there, a quarter of my data there, and a quarter of my data there. Now, these box plots are not supposed to be symmetrical. They're not pretty pictures. This line here can be longer. This line here can be shorter. The line in the middle, this median, as you can see here, doesn't have to be in the middle of the box. And a lot of that in the next video helps us sort of talk about the shape of this data. In many cases, we don't like dealing with fractions. Come on, guys, you know as well as I do, we hate fractions. So we like percentages. And again, we can think of this, that this is 25% of my data, there is 25% of my data, there is 25% of my data, and there is 25% of my data. But what does this have to do with the price of fish? Well, nothing, because what does anything have to do with the price of fish? But what we notice is that this value here, at the very, very end on that left-hand side, is what we call our minimum value. Oh, tick, that was one of the things we wanted. This value here, at the end of the 25th percentile, all right, or when that 25th percentile finishes, is my Q1, my lower quartile. So it's halfway between my bottom 50% of my data. Here is my median. We know where the median is. It's smack bang in the middle. What about this Q3? Well, if we go back to my previous one, we found the interquartile range, it's halfway between my upper 50% of my data. Or, now this is where people get confused, and I'll do a little bit more on this in a moment. But if you think about it, if this is where 0% of my data is, then here is 25% of my data. This point here must be my 50th percentile, and this point here is my 75th percentile, and by the time I've got here, I've got all of my data. So we're starting from 0% and going to all the way to 100%. So my upper quartile actually is where my 75th percent is. All right, that's where 3/4 of my data is. And finally, this value here is my maximum, my highest value. So understanding that is just amazing. What you've just got to realize, as I say over and over again, that a box plot talks about 25% of data. So let's have a look at drawing a box plot. If we know what they look like now, we should be able to draw them. And again, remember, our 5-number summary is basically this here: minimum, lower quartile, median, upper quartile, and maximum value. Now, all of these notes can be downloaded from mathsguru.com, PDFs, download them, cut them out, and if they're useful, stick them in. But to be able to draw any diagram, we must make sure that we use a sensible scale. The number of people in life who draw graphs with just odd scales, sadly, it shows a lack of understanding. And so we have an example extracted from the Cambridge Further Mathematics textbook. Thank you so much, Cambridge, for allowing me to use your questions. You guys are just da bomb. Hopefully I'm doing you proud. So we've got a question here that says, the STEM plot shows the distribution of life expectancies in years in 23 countries. Now, as it turns out, this example was used in a previous video and a previous chapter. So I like the way that they actually follow through. What do we have here? So life expectancy in years. We know how to read a STEM plot now because we know what that stem and that plot is. And if you don't, there is a video on this. Go and watch it. And so we can read off my 5-number summary. So I actually am going to write out minimum is equal to 52, not 2, 52. My lower quartile, or Q1, is given by 66. My median is given by, what does it say my median is? 73. My upper quartile is 75, and my maximum value is 77. Having written those down, I'm now going to come up with a sensible scale. So the first thing I'm going to do is draw a line, hopefully not hitting my head. And I know my lowest number is 52, and my highest number is 77. So actually what I'm going to do is I'm going to go between 50 and 80. Job done. So 50, 60, 70, 80. So there's, split that into thirds gives me 60, 70 and 80. I now know that's 55. I know that that's 65, and I know that that's 75. And do you notice what I'm doing here? I'm just adding on those extra bits to make it that bit more accurate. Now, I'm drawing with electricity. This isn't actually a pen, it's just, I don't know, it's electricity basically. So you have the advantage of A, making your lines pretty straighter than mine, and B, making it much more accurate, because you're going to have to do that in your exam. Okay, so the first things first, I'm going to do my min, and I'm just going to put a little bit of a line where my min is, or a little dot where my min is. So it's 52. Let's say that this point here is my 52, and I'm just going to draw a tiny little vertical line. And I'm going to do my lower quartile at 66. Now, when my lower quartile, it's a much longer line. It doesn't touch the axes, it's a longer line. So there's my lower quartile. My median, 73. Now, that's exactly the same line as, or the same length of line as my lower quartile, and in fact my upper quartile, which is at 75. There is my upper quartile. Now I know, because that's the middle section, that's my middle 50%, probably the most important part of a box plot. There I can join that in my box. And then finally I've got my max of 77, so that's just a little line there. And what I do now is I join those together with a beautifully straight, oh, almost did it, line there. And ladies and gentlemen, there is my box and whisker plot with my 5-number summary. They're my lowest value. I've got my lower quartile, I've got my median, I've got my upper quartile, and in fact, I've got my max. Now, as I say, in the next video, we will now be able to use that box plot to start describing my data. We can look at the center, the spread, we can look at any outliers, but we've got to get to outliers first, okay? So, oh, it says here, remember to make sure that your scale has a label. What was it? Life expectancy in years. So because they've told me that, I'm just going to write life expectancy, and in brackets, years. Now, excuse my handwriting, it sucks on this thing. Normally it's a lot better. Now, this is a CAS-enabled course and technology is here to make life easier for you, and it just so happens I'm about to show you how to do that. So when I load up my CAS, and it's the Casio ClassPad, which is an amazing calculator. I know there's the TI Inspire as well, and probably others. I used to love the TI Inspire, but the Casio's just pipped it for the moment. And if you are a TI Inspire user, I will do videos that will show you how to use the TI Inspire, just not at this time. Sorry, guys. So what we're dealing with? We're dealing with statistics. So I suppose I'm going to hit the statistics button on my calculator. And lo and behold, as if by magic, up comes my data already. Now you're going to say, what do you mean data? Well, the question says here, display the following set of 19 marks in the form of a box plot with outliers. And I have entered all of that data in already. You genuinely don't want to sit here and watch me enter all that rubbish in. So how do we do a box plot? Well, I've already shown you how to do histograms before. Very similar. So I'm going to highlight with a red arrow now that you're going to hit this button here, and you want to select the type of chart you want to draw. Now, obviously beforehand, if I scroll up, we had the histogram, which was just below, near towards the bottom of that line. In this situation here, we want med box. No idea why it's called med box. If you know, leave a little comment below, because I have absolutely no comprehension. Barry's at it again. We want to draw on. Now our X list is, where was that list of data? Well, I didn't name my data, so I've just left it as list 1. My frequency is at 1. And one of the most important boxes you have to tick is that one I've just selected there, show outliers. Now we'll come to outliers in just a moment. But when I hit set, I'm done. Hold on a moment, it's not drawing my graph. No, because I need to tell it to draw the graph. And how do we do that? Yes, we hit the draw graph button, and as if by magic, up comes my box plot. Now in this situation here, we can, if we want, resize that bottom box to make it easier for us to see. I generally have no idea, although I like the Casio, this makes no sense as to why it put it at the top of my screen. Why it put it at 8. No idea whatsoever. But anyway, how do I now look at those values? Well, again, I hit my little X, Y button, and you'll see that per ink cross come up. Now, in that situation there is an outlier. Now again, we'll talk about outliers in just a minute, but if I now move it to the right, we notice that it stays on that little line. Now that's not my minimum value in this situation, and we'll come back to the difference in a second, but that little square that I've now moved onto there, which says min x equals 3, that is my minimum value. It is also an outlier. When I go across to here, notice how it says x equals 21, but then it goes to Q1 equals 23. Make sure you notice that Q1 is basically saying lower quartile, lower quartile. So my lower quartile is 23. It says median equals 30. Could this calculator be any more helpful? Median equals 30. One more, then Q3, which would be much better if it wasn't actually on top of that axis. And then we have my maximum value of x at 48. So drawing box plots on this CAS is so simple, it is just awesome, yeah? But as I say, don't forget to tick the box that says show outliers. So I suppose the big question now is, how did the calculator know what an outlier was? Yeah, how did it know that value? How did it choose? Did it just do it by magic, by a bit of voodoo? Or no, actually not. Barry has been sitting in that office again, thank you Barry, and he's basically said, well, I suppose we need to decide which data can be ignored. And he said, well, how do we do this? And he thought about it on his own. He did a few Sudoku. He turned the lights off and sat in the dark. He dribbled to himself and he came up with a formula. And basically what he said was this, that because in maths we need to sort of make sure that we know what data is on the outside, I'm going to come up with that an outlier is given by the value of Q3, otherwise known as my upper quartile. And I'm going to add on to that 1.5 times my interquartile range. Now we already know that my interquartile range is that middle 50% of data. So what he's effectively saying is, well, we've got some sort of error here. I just want to look at this middle set of data. We'll give it a bit of a fudge factor, this 1.5 business. And when I add it onto Q3, that is the value bigger than, there will be an outlier. So any value bigger than my upper quartile plus 1.5 times the interquartile range is an outlier. And what about here? What about this outlier here? Well, we can have outliers on both sides of this box plot. And so again, what he said was, well, if we've used the idea of the upper quartile plus 1.5 times the IQR, then this one here is going to be the lower quartile minus 1.5 times the IQR. And as you can see here, ladies and gentlemen, there is a visual representation again. Yes? Now, one of the things I want to point out is people think that outliers don't count. And of course they count. You can't just ignore them. They're there. And so, as my calculator showed a moment ago, you must know that that point there is still my minimum value. This point here is still my maximum value. This line here is still my median. This here is my lower quartile, as known as Q1, and this one here is still Q3, okay? This line here is still important to us. Notice it doesn't go all the way to our fence. I mean, why they call it a fence, I've got no idea. But anyway, Barry, you probably outdid yourself there. This value, this end of this line will actually be one of my values. Yes, it will probably be the third value in. How do you know it's the third value? Well, this was the first value. This was the second value that made them outliers. And then the third value would have been where my line starts. Likewise, this here would have been my last value. And this line ends at my second last value. All of this will become clear as we move through the course. So, knowing what they are, let's have a go at trying to read some. And again, here is an example from the Cambridge Not Essentials textbook series. I keep doing that because I'm also recording 7 to 10 videos. It's the Cambridge Further textbook series. So, we have a we have a box plot, a box and whisker plot shown here. And it says, write down the values of the median. Now, before we go any further, it's so important to know what that scale is. It's obviously going up in tens. But how many divisions are there between each of those? And if you count, you'll find out that there are 5 gaps. So each of those gaps must stand for 2. Yep, so I'm going to zoom in just a little bit to make it easier for us to see. Now, fingers crossed, I've either moved my head or I've made myself significantly smaller so that this actually fits in. Moving it over just a little bit more. So the median, where is the median? Well, it's the middle line. So if we read off this middle line, where does that come to? Well, 32, 4, 6. So, according to this, the median is 36. What are my quartiles? Again, reading down, we would say that was 30, and that would be 44. So my lower quartile, Q1, would just read off as 30, and Q3 would be, what do we say? 44. The interquartile range, well, we can find the interquartile range now because we've got my upper quartile and my lower quartile. So my IQR is going to be 44 minus 30, which gives me 14. This stuff's amazing, just reading off of a graph. The maximum and minimum values, this is the one that tricks people, right? Remember, this is my my minimum value. Even though it's an outlier, it is still my minimum. Read that off. What does it say? I reckon that's actually supposed to be 4. So my minimum is equal to 4, and my maximum, which is this one here, what do you reckon, 92? Let's say it's 92. The values of any possible outliers, well, we've got that now. We can see those outliers because they're the ones with the circles. So what did we say? We had the values 4. What do we have there? Let's say that's 70, 84. So 70, 84, and we'd already said the maximum value of 92. Rubbing these out to make it a little bit more sensible. The smallest value in the upper end of the data set that will be classified as an outlier. Whoa, what does that mean? Well, as usual, maths is trying to trick us by using long language. What that's actually saying to us is find our upper fence. And if you remember, our upper fence was given by Q3 plus 1.5 times the interquartile range. Okay, so do we know the value of Q3? We do, it's 44, plus 1.5 times my interquartile range. And we found the interquartile range of 14. So what I'm now going to do is load up my calculator. I'm going to put it back into let's put it into the main mode. And I'm going to do 44 plus 1.5 times 14, and gives us a value of 65. So my upper fence is given by 65. What that means is any value bigger than 65 now will be classified as an outlier. And part G, the largest value in the lower end of the data set that will be classified as an outlier. Again, it's asking us just to repeat it now and find my lower fence. So making sure that we can fit this on the screen, lower fence, we know is Q1 minus 1.5 times the IQR. What was the value of Q1? Can't see it, so it's 30 minus 1.5 times 14. So let's do that on my calculator again. So 30 minus 1.5 times 14 gives me, oh no, not plus, gives me the value of 9. So any value smaller than 9 will be an outlier. And that makes sense because we had a value of 4 here that was put by my calculator on my diagram as that circle. See, now anyone who says these are difficult, hopefully will now realize they're actually not until we throw in percentiles. And I promise you we are getting towards the end of this video as well. What is a percentile? Well, funnily enough, we've already dealt with it. I've already said to you, if you remember, a box plot can be split up into 25%, 25%, 25%, and 25%. My handwriting is getting worse. Yes? And what you need to realize is this value here is 0, 25, 50, 75, and 100% of my data. And this is where questions throw people. So let's have a look. Another example taken from the Cambridge. I've got to get sorted on this. Further textbook series. For the box plots shown, estimate the percentage value. So they don't want the values now, they want percentages of less than 54. Let's zoom in so that hopefully we can work out what this is. So the percentages that are less than 54. Well, here is my value of 54. What do you notice? Well, that's actually my lower quartile. And we're looking for the percentage that's less than that. And we know that that section there stands for, thank you very much, 25%. Whoop, whoop. What about the next one? Less than 55. Well, let's do it again. We're looking for 55. It just so happens to be on my median. So how much of the data is less than my median? Well, bearing in mind this is 25%. And this here is 25%, then we're looking at 50%. Less than 59, I reckon they're trying to trick us here. Here is 59. What do we notice? How many sections of my box plot have I got? 1, 2, 3. I've got 25, 25, and 25, which is 75% of my data. Greater than 59, this is definitely trying to trick me now because greater than 59, we're just actually looking at it the other way around. So again, how much data is on that right-hand side? Sorry, right-hand side for the camera. I got getting confused. Well, this is my upper quartile. 59 is my upper quartile. So up until the upper quartile, 75% of the data. Above it must be 25% of the data. Again, I'm just looking for quarters here. Oh, come on. Between 54 and 59. Between 54 and 59. How many sections of my box plot are there? 2. What does each section mean? 25%. 25 and 25 is 50%. And finally, between 54 and 86, well, there is 86. It doesn't matter about this outliers. We know that that is in the final quarter. So between 54, there's 1, 2, and 3 sections. And so altogether, that would be 75% of my data. See what? This type of question, I've seen this type of question in the further maths exam so many times because it's easy to trick you. Well, ladies and gentlemen, I think it is just about time for me to call it a day. Let's scroll to the top so we can just recap that actually this was the 5-number summary and box plot video. Thank you so much for staying along. If you haven't already done so, can you do me a favor and subscribe? A doohickey will appear over there shortly that will allow you to do that. And if you can tell your friends as well, it would be greatly, greatly appreciated. I know I said this at the beginning. I'm very needy. More videos to come. Thank you very much for watching. There is a video loading underneath now, that doohickey, that will allow you to watch another video in this series. Otherwise, if I'm not, I hope to see you again soon. Take care. Have a good day. This is Maths Guru, signing off.